What is SOHCAHTOA and how is it used in right triangles? Remember that this is video number 2 for section 8-3 and 8-4 out of your textbooks. And now we're going to be able to figure out how to use SOHCAHTOA for right triangles. Here's a reminder of how your notes should look like for this video. And this is video title number 2. And make sure you draw your notes. And then once you're done, go ahead and review your notes and create your summary, which should be about 2 to 3 sentences in length. I also want to remind you that this video is a little bit lengthy, so make sure that you pause, you write everything down, and then continue when you're ready to follow along. Okay, this slide was in the last video, but I just want to remind you about SOHCAHTOA and the 3 trig ratios we're going to be using for right triangles. Remember that A represents the angle, and the opposite over hypotenuse is your ratio. And if you plug it into your calculator, you should be given a decimal answer. But there is a way to get it just as a ratio or just as a fraction. But most likely it will be a decimal answer, okay? And then whenever you have your ratio, you can also use your ratio to then get your angle. So you can use the angle to get the ratio and then use the ratio to get the angle. And we're going to be doing that back and forth. And it's going to help us not only locate the sides of a right triangle, but also help us to find the different angle measurements as well. So let's review SOHCAHTOA. So means sine, opposite over hypotenuse. Sine A, opposite over hypotenuse. Ka is cosine for adjacent over hypotenuse. So cosine of A would be adjacent over hypotenuse. And TOA would be tangent of A, which is opposite over adjacent. So tangent of A is opposite over adjacent. Write this at the top of your paper anytime you're solving these types of problems, and it will really, really help you. You will need a scientific calculator. The picture of the calculator that I have here and here are both from my scientific calculator on my computer. So you can either look up yours on the computer, you can download one to your iPhone for free, or even your smartphone. Any type of phone that's a smartphone, you can download an app for a scientific calculator for free. It works on a tablet. You can get an app for a tablet or for your iPad. Whatever you have, there's many ways to get a scientific calculator. And if none of those ways are open to you, the last place to look is the store. They have scientific calculators for extremely cheap. I think they even sell them at the 99-cent store, but definitely Target and Walmart have them, okay? So you must invest in getting a scientific calculator. So we're going to be finding the ratios. This is the simplest form of question, is finding the decimal value of the ratio of a given angle. Remember, ratio is just a fraction, but we're going to get the decimal values of these fractions. So like 3 over 4 would be 0.75. But these ones are going to be pretty extreme, so we have to use the scientific calculator to get them. So in order to find number 1, you're going to type in sine of 32. So this calculator was the first one that I used. And it's not really sine. Sine doesn't work. Instead, you're going to have to do, you won't be able to type in exactly what you see here. That's what I meant. For this calculator, I had to push 2 for 32 and then sine. And once I was done with that, it gave me this decimal. And if I told you to round to the nearest tenths or hundredths, let's do hundredths, you'd write 0.53. So I just round to that 2 right there. Okay, so now let's look at number 2. Cosine of 23. I had to first type in 2, then 3 on the calculator, and then I pushed cosine, and it gave me this decimal. And so my decimal value for these, remember, 23 is the angle, just like 32 was an angle measurement. Cosine of 23 is going to give me 0.92. Okay. Now, if you're not using a computer screen, then your calculator may look something like this, and it's the same process. Sometimes you push sine first, then the number 32, or you'll push 32 first and then sine. It depends on your calculator. I want you to go ahead and do number 3, 4, and 5, finding tangent and sine. Bring your work to class. Using ratios to find angles. We have just found that a scientific calculator holds the ratio information for sine, cosine, and tangent for all angles. That's why it has these buttons, because it has all that information for those different angle measurements for these different trig ratios. It can also be used in reverse, finding an angle for a ratio. So, for example, if I have addition, the inverse of addition is subtraction. Inverse of subtraction is addition. Inverse of multiplication is division. And inverse of division is multiplication. Even something squared, like if I had x squared, the inverse of that would be the square root. So everything has an inverse. There's always a way to undo something within mathematics. And so when you have our sine, if you want to undo sine, you'll just have to take the sine inverse of both sides. Same thing with cosine. If you have cosine and you want to get just cosine away and just find the angle measurement, you can do cosine inverse. So we're going to use sine inverse, cosine inverse, and tangent inverse function keys. And usually you'll have to shift. Like here, you'll have to end up shifting to get those inverse functions. Or you'll have to choose shift to change all your values if you're using it like on an iPhone or something, or a smartphone, or your computer. Let's look at two examples. We have the sine of x is equal to this decimal. And we want to find out what the angle is. So we're trying to find out. Remember, this x right here was next to the sine or cosine or tangent is the angle. So if I'm trying to find x, I'm trying to find the angle. And to do that, I need to undo this sign. Get the sign away. Eliminate that sign. And to do that, I take the sine inverse. If I take the sine inverse of this side, I just get x. And if I take the sine inverse of this side, I'll plug that into my calculator. I'll do shift sine, get sine inverse, plug in the decimal, and it will give me 6.4. And that is an angle measurement. So angle measurement. Let's look at a second example using cosine. Cosine of x, remember x is an angle and is equal to this ratio or this decimal, 0.8988. And we want to find angle x. To do that, I just need to take the cosine inverse of both sides, and I would then get this cosine away and then be able to do the cosine inverse of this side. And if I do cosine inverse of that decimal in my calculator, it gives me the angle measurement of a nicely even 26 degrees. So then, if I want to check my answer, I would take my calculator and type in cosine of 26 degrees, and that would give me 0.8988. Now let's begin to apply the information we just learned, not by just looking at different problems in terms of with no pictures, just looking at data and trying to plug it into our calculators. Now let's actually apply it to looking at the right triangles, because that's why we use sine, cosine, and tangent. So to find a missing angle from a right-angled triangle, we need to know two of the sides of the triangle. If we know two of the sides, then we can choose the appropriate ratio, sine, cosine, or tangent, and use the calculator to identify the angle from the decimal value of that ratio. And that seems like a lot. We're going to go over this in class again, but let's go ahead and write down these steps. To find angle C right here, we are first going to identify and label the names of the sides, and we're finding angle C, which means angle C is our chosen angle. And then we got to choose the ratio that contains both of those letters. So let's go ahead and discuss a little bit what I'm talking about here. Let's look at part A first. For part A, I need to identify and label the names of the sides. So if we're looking at angle C, then what is right next to angle C, touching angle C, is going to be our adjacent side. So I'm going to go ahead and write, use a different color. This is going to be adjacent. And that's an abbreviation for adjacent. And remember, we're looking at angle C. I'll go ahead and circle it. Next, whatever's opposite 90 degrees is always going to be the hypotenuse. So 14 is hypotenuse. And then opposite C would be the opposite side, which is over here. And notice there's nothing there. Okay? So now, since we have the sides labeled, it helps us to choose the ratio that contains both of the letters. Let's continue this example on the next slide. Okay, so if we looked at oops, dang, I hate when that happens. If we look at SOHCAHTOA, we can go ahead and look at the three trig ratios, see which one will work. And obviously, you know that cosine will work, but let's see why does cosine work, because I want you to be able to explain that. Let's first look at sine. Sine is, and we're looking at angle C, sine would be opposite over hypotenuse. And this will not work because we're not given any length for opposite. And we're also looking for angle C. So there's two unknowns there. There's not enough given information for me to use sine. Cosine does work because cosine is going to be, I could do a different color. Cosine is going to be adjacent, which is 6. So 6. And it's going to be the hypotenuse after that, which is 14. Notice I have two numbers that I need. And this is the actual given ratio. And if I plug that into my calculator by pushing sine inverse and then plugging in 0.4286 in my calculator, then I would get that C, the angle measurement, would be 64.6 degrees. So that means that this angle right here, C, is going to be 64.6 degrees. And I found that angle by using the trig ratio. Let's take a look at our next example. Here we need to find angle X, which is here. So this is our chosen or given angle to find. So we're going to focus on that. This side across or opposite angle X is our opposite side, and they gave it to us as 8 centimeters. And then adjacent or A to my X angle is 3. Remember, adjacent touches the angle. Now, if you look at SOHCAHTOA, which trig ratio will work the best? Well, since I'm given O and A, I need to use tangent, and that's what they did here. They said tangent of A, or in this case it's really tangent of X, is going to be 8, which is opposite, over adjacent, which is 3. That is this decimal here. So now in my calculator, I will type in 2.6667. And then I would do tangent inverse. And notice I'm on shift right now for this calculator on my computer. And I would get the angle measurement, which is 69.4. So this angle X is 69.4 degrees. How did I find that? I used the trig ratio tangent and then the ratio from that to help me find the angle measurement. Let's look at one more example. This time we're going to involve sine. So if we look at the given angle, which in this case is angle Y, we're going to look for the measurement of angle Y, and we're given the opposite and the hypotenuse. So if I look at SOHCAHTOA, they gave us opposite O and the hypotenuse, which is H. H. Hopefully you can kind of see that better. So the one that has O and H is sine, and that's why they use sine of angle A, which in this case is sine of angle Y. Gotta change that. Sine of angle Y. Y. Sine of angle Y is opposite over hypotenuse, or 10 over 12. Here's the decimal. In my calculator, I'll type in 0.8333, and then I'll type in sine inverse, and that would give me the angle measurement of 56.4. And that's that angle measurement here, 56.4 degrees. How did I find that? I used the sine ratio opposite over hypotenuse, based on what's given from the triangle. Not only can you find an angle measurement given some sides, but you can also find a side from a triangle. So to find missing side from a right angled triangle, we need to know one angle and one other side, and that's it. So note, if cosine of 45, remember 45 is the angle given, and they gave me a side of 13. This should be the hypotenuse. To leave x on its own, we need to move the divided by 13, and it becomes a times when it moves. Really what it's saying is that if I put this all over 1, I can cross multiply, and I would get x times 1 is equal to cosine of 45 times 13. Plug that into your calculator, and you would be given this side length of x. Here's the first example on how to find the side length. Let's see what we're given here. We're given that an angled measurement of 30, so that's going to be our angle of focus. Then we're given the we're not given opposite, but we need to find, not opposite, the adjacent. We need to find adjacent, but we're given hypotenuse. So now we can find the adjacent side pretty easily by using a cosine function. Cosine, because we're using adjacent over hypotenuse. If I looked at SOHCAHTOA, I would see that if I'm using adjacent hypotenuse, I would need to use cosine. So cosine of angle A, which is in this case 30, because that's our focused angle, cosine of 30 will be K, which is adjacent, over 7, which is the hypotenuse. And now I will cross multiply, and I'll get K to equal cosine of 30 times 7. Plug that into my calculator. So for this one, for the calculator from my computer, I would need to first type in 30, then cosine, and then I would need to multiply that answer by 7, and that would give me 6.1 centimeters for the side length of K. So this length here equals 6.1 centimeters. How did I find that? I used the cosine ratio, adjacent over hypotenuse. That last slide was one type of example of finding a side from a triangle, but there are occasions when the unknown letter is on the bottom of the fraction after substituting. So you could get something like this: cosine of 45 equals 13 over u. U would be the hypotenuse, 13 would be the adjacent side to 45 degrees. In order to do this, we're going to do cross multiplication again. Put this all over 1, cross multiply, and I would get u equaled cosine. Oops, sorry, that's incorrect. I would get u times the cosine of 45 is equal to 13. But remember, we are trying to, they wrote it here. We are trying to locate what u is. So let's go ahead and divide both sides by cosine of 45. Cosine of 45. So then my calculator, I would type in 13 divided by cosine of 45, and that would give me the u. And then I can find that missing side length. Just a reminder, this works for tangent and sine. I just don't want to do the same thing 3 times. Let's practice 2 examples. For the first one here, we are given the adjacent to 30 degrees, but we're not given the hypotenuse, and that's actually what we need to find. We need to find x. So I'm going to make a ratio, and if I'm using adjacent, which is given, and trying to find the hypotenuse, using this angle as my focus, then I can use cosine, because cosine is adjacent over hypotenuse. Cosine of 30 then would be 5 over x. I would use cross multiplying and then divide. So I would get 5 divided by cosine of 30. Plug this into my calculator, and I would get 5.8 centimeters, and that's the missing side length here. Same idea here, except for I'm given now looking at the angle, this given angle, I'm looking at opposite and the hypotenuse. And if I'm looking at opposite over hypotenuse, I'm going to use sine. And if I make my trig ratio, I would then get sine of 25, which is my focus angle, is 8 over m, or adjacent over hypotenuse. I would use cross multiplying, and then I could find m by plugging this into my calculator, and it would be 18.9 centimeters. So now you figured out how to find a missing angle given 2 sides. You were able to find a missing side given a side and an angle, and you figured out how to use inverse trig functions along with the first 3 trig functions. A lot of information. So let's sum it up on the next slide. Okay, so here's this brief summary of what we just learned through the 2 videos. We're going to be using sine, cosine, and tangent, or SOHCAHTOA, to help us define missing side lengths and angle measurements of right-angled triangles. And you want to make sure you always write this at the top of your paper. It will be on your board when you come into class tomorrow. If we're looking for a side length, we always have to remember to look at the actual degree that's given. This is our focus angle. Then we can decide on what trig function to use based on what we need to find and what side is given. Once we figure that out, we can build our ratio and solve. For number 2, another example is when we are given a focus angle. If we need to find a side length, we can also use tangent for this. And to do tangent, it would be opposite over adjacent. And remember, our degree focus is 50 degrees, and you could find out the missing side. And then there's also another case. What happens if you're not given the angle measurement? In these 2 cases, you were given angle measurements. Now you're not given it. How do you find the missing side lengths? Here, or excuse me, not missing side lengths, but the missing angle length. You can use the 2 sides given. You can build your trig ratio. Then you can use inverse. in your calculator, and it'll give you that angle measurement that you need. Remember, inverse always gives you your angle measurement. Remember that it's possible to have what's not given to you in the denominator. Then you'll have to do a little bit more simplifying. And if your answers in the denominator is one quick answer for you to find out that other missing side length. So this kind of summarizes everything we just discussed. If you still have some trouble, make sure you look through all the videos. And I will see you in class tomorrow.